Good afternoon. Good afternoon. How's everyone doing? Good? Good. Excellent. So, I have good news and bad news. The good news is we're going to be healthier. The bad news is you have to do some exercises with me. So, who heard about this paradigm before, which is fresh body, fit mind? A couple. Is it because you saw a previous talk of mine, or is it? No. Okay. Good. So fresh body, fit mind. So what does it mean? It means that in order for for your brain to function, to get those the blood and all the brain juices into there, you need to move and you need to exercise. Right? You're supposed to move. You're supposed to be fit. So I will ask you to stand up for a second, please. It's going to be a very, very simple exercise that we're going to do. So I'm going to show you my back. It's going to be very simple, so apologies for showing the back, but what you need to do is raise up your arm so that your elbow is in line with your eyes, like that. Yeah, and now open up your palms and start clapping. Thank you. So I have this slide because a lot of times it's a 50-50 split, right? Half the people are like, oh, okay, I see. Other 50 are still like, ah. So, thank you. So what happens, I collect these pictures. Every year I have my yearly review. I send it to my boss and I'm like, standing ovation again. And he's like, what is he, how can you make images like so special? But anyway. Okay, so on a more serious note, so I'm here. Can you, if I stand here, you can't see what's there, right? Better? Okay, cool. So I'm here to talk to you about images and image optimization. I think I have about half an hour. This talk is meant to be an hour, so we're going to, go through it as quick as possible. So I'm going to start with a couple of statistics. So I don't know how many of you know the Web Almanac project. Web Almanac. One, yes. Okay, so now all of you will know. There's a link, so hopefully we'll be able to share this slide. So Web Almanac is a project. No, you can't read that. It's fine. It's fine. It's almanac.htparchive.org. So it's a project run mostly by Google and some other contributors. Anyone can contribute to any of the chapters. They have lots of chapters on JavaScript, CSS, HTML, accessibility, media, 20 plus chapters that basically use HTTP archive data, and they try to run some clever analytics on that data and understand what happened in the web on a yearly basis. So this particular statistic is from the media chapter from 2022, and basically it just says that 99.9% of the pages that are in that HTTP archive database make a request to an image resource, which pretty much tells me that every single website pretty much makes a request to an image resource. Now, here's another one. So I do work for Cloudinary, so we have our own sort of visual media report thing happening. This is, again, from 2022, and this is just Cloudinary, right? And there are other image CDNs and there are other image providers out there today. So just Cloudinary handled 199 billion requests per month in 2022. So that's a lot of data going on the web in terms of images. And then the last one, talking about diversity and stuff. Usually we think, okay, I need to optimize for desktop and mobile. Cloudinary sent 2.7 million requests, so it's 2.7 million image requests to Sony Bravia TVs per month. Maybe optimize for Sony TVs as well. Just FYI, okay? I just thought this is a funny little statistic. And also, the title of this talk is an image is worth, 1,000 kilobytes. The saying is, of course, 1,000 words. And that's because about 50% of our brain is involved in visual processing. Again, proof is in, the link. Some very clever researchers investigated that. So what does that really mean? It really means that you can convey a message much easier using a picture than with words, right? But then failing to optimize those images is actually going to be a very, very, it's going to be a problematic thing for you. And the reason why I say that is because usually I have this conversation with people and they say, well, image optimization is, it's easy, but you need to understand some of the intricate details to be able to do it right. And getting it right is really, really difficult. Now let's go back in time to, this actually was, who knows Henri Vatica? A few of you, okay. So if you don't follow him, he does some really good, he shares some really good content in terms of web performance on Twitter. And in, excuse me, in 2021, he said this: the image element turned 25 in 2020. It both engages users with delight and enrages developers. And I think it's a very, very good way of talking about the image element itself, because adding images to your application is going to be really pleasant for the users, but getting it right with all the AVIF, WebP, PNG, all these formats is very, very difficult. And I also went back to the HTML spec in 1995, and I found the description of the image element, right? So this is how it started, this is 1995, and then the attributes of the image element were align, alt, ismap, and source, right? Very easy to work with. Now we look at 2022, source width, height, source set sizes, loading, decoding, style, etc., etc. So it became a lot more complex. So what I'm going to try to do is, I try to explain to you a couple of things. Adding images to a website is easy, said no one ever. I said this as well. So we're going to talk about a couple of things: format, content of the images, the devices that you want to send images to, responsiveness, delivery, and how would you want to decode your images. Now, as I said, I have half an hour, so I'm going to focus on some of the most important things. And of course, we also will need to mention core web vitals a little bit, because that's an important aspect of web performance. And often what I also find is a lot of people talk about, so when they talk about web performance, they usually talk about JavaScript, right? JavaScript, and I'm not saying that's wrong, that's absolutely correct. You should do all sorts of optimizations for JavaScript, but if you think about the resource sizes, images and videos will always beat your JavaScript bundle sizes by, tenfold, right? Even though if you have, maybe you have a 2-3 megabyte JavaScript bundle, having 500 kilobyte images will beat that. So it's very important to understand the effect of those as well. Okay, so in terms of tooling, there are lots of tools out there today that you can use to optimize your images. Okay, some of them are available online, some are desktop clients, some are NPM libraries, and there are, of course, image CDNs that do all of this work for you. By the way, Squash also has a CLI, right? So you can install that via NPM. I just didn't update this slide. So what you need to understand: image formats. We're not going to talk about user devices. We'll talk about core web vitals, and then probably maybe placeholders and some loading techniques as part of this talk. At Cloudin, we also created what we call an image format battle card, which pretty much lists all the available image formats that are out there on the web. And as you can see, JPEG has been around since 1992. And JPEG is, in fact, the most widely used image format on the web today. But it's also because it's the oldest, there are some other formats out there that are more suitable for the web. When we released this particular beta card, there are a lot of other elements that we use to compare these image formats. So this is just a snapshot of that. We also put JPEG XL in there. It's well, politics. Who saw the JPEG XL drama on Twitter? And some of you, okay. So JPEG XL. The reason why I'm not involved in that, but it's one of my colleagues is part of the JPEG committee, so he was very vocal about what JPEG XL is and how it works. Google Chrome supported JPEG XL behind the flag until version 100 and whatever, so quite the latest version, and now they removed support from it. And just read up on this, why. Okay, FYI, Google also authors WebP. So, okay. So here's another statistics, right? This is, again, from Web Almanac, so you can see in 2022, which were the most used image formats. So you can see JPEG, PNG, GIF, WebP, SVG, and some others. And, we also hear a lot about AVIF these days, right? So just notice that how AVIF is not even, it's probably a very minuscule slice of the overall pie. So JPEG is still the dominant image format. And WebP is also used, everywhere, but still it's a very small portion of that pie. And it's I wouldn't like to see PNG there for a reason, but again, more on that later. So let's talk about something that a lot of, when I talk to people, they don't really understand what this is, and that's fidelity. What is image fidelity? So fidelity of an image is image fidelity is trying to, when you optimize an image or you change the format of the image, it's you trying to keep the original, the details of the original image as closely as you can. Okay, so for example, you take a picture of a sweatshirt. You then want to create a high fidelity, say, AVIF of this. It means that it should still show you all the fine details of the fabric, for example. Okay, and it's very important to understand because I don't know if this is going to be visible on the screen, but let's say you have created a low fidelity AVIF and a high fidelity JPEG. Now, just ignoring the fact that you don't understand, anything about low fidelity. Let's just talk about AVIF and JPEG. You create an AVIF, you create a JPEG. And so the AVIF is going to be a fraction of the size of the JPEG. Okay, so it's going to be maybe, the JPEG is going to be 500 kilobytes, the AVIF is going to be maybe 50. And you're like, okay, this is good, I'm happy with it, but if you look closely, oopsie, you lost a lot of detail, right? So in the JPEG, you can still, again, I don't know if you can see it from there, but you see the details of the bricks. Whereas the low fidelity AVIF is just a smooth surface. You lost the fine detail. Now, if that's something that you intentionally want, great, fine. But you should be aware of the fact that that is a different representation of the original image. You lost a lot of detail. And this is, again, depending on the fact what you're trying to do, it's either fine or either, needs some understanding. Here's an interesting one. This is not really related to the web. It's called the Xerox Incident. It's happened many, many years ago. I don't know how many of you heard about it. You can actually Google this. So what happened was, what you see here on the left is the document that got scanned, and then on the right, what you see is what the scanner produced. So that was I'm forgetting the actual encoder in the Xerox machines. Those are now banned forever, especially in the Germany, Switzerland, and Austria, because they had a lot of issues with this. So this is how you gain money, right? So you scan something, and then because of a low fidelity encoder, you now get completely different numbers. And now that's what you submit to the taxman, and you either lost or gained money, and no one knew what was happening. Now imagine this happens for like a bazillion amount of documents. Good luck fixing that as well. Okay, so what does this all mean? So this is just a theoretical example, right? So let's assume that you work at a company where it's an e-commerce shop, and then your boss is like, well, images are not loading fast. I heard about this new image format. Try to do something about it. And you're like, okay, so I could create AVIF. It's going to reduce the bandwidth. You could potentially save money. It's going to produce, nice-looking images. And it's going to provide your users with a great experience. The website is going to work fast, it's going to be snappy. But because you produce low fidelity images, you could lose, the original color, the finer details of the fabric, which could also result in unhappy customers at the end of the day who will receive the product, open it, and they're like, what the hell is this? It looked totally different, right? They go to the screens, because that's what my wife is doing, don't tell her. She goes to the screen, she's like, this is not orange. And I'm like, what did... Anyway, and I made a video. So this, again, I don't know if this is going to be visible on the screen. It's not playing yet, but the original is a black leather bag. And when I created an AVIF version of it, it becomes dark green, and it kind of loses the detail of the fabric. Okay, so it's switching in between the two. I don't know if that's visible from where you sit. So I'm going to play it again. Okay, so it's kind of like dark green. You can see, okay, you can. I'll show it to you later. Can someone see it? Some of you. Okay. I'll show it on my laptop. So again. Well, the original is black. The AVIF is kind of dark green. But well, you're a good customer. There you go. But anyway, I can show it to you on my laptop. It's a lot more visible when you're a little bit closer. Okay, so all that being said, a lot of discussion has been around core web vitals, right? And it's very So I don't know how many of you heard that, but Google, when was that? Maybe 12 months ago, they released a study about improvements to Core Web Vitals, and they said cumulative layout shift. Most of the websites are now getting it right. FID, no one's struggling with it. It's fine. LCP, they said, is still causing a lot of issues to a lot of developers. And of course, it's going to be very difficult to get it right because, especially on a media-heavy website. So usually, these days, the size that you visit, it's very likely that the LCP, the largest contentful paint, is going to be an image of some sort, a hero image. And then loading that the right way is actually very, very difficult. And so I'm not going to talk about first input and CLS, so I'm just going to focus on LCP. So the LCP calculation is actually made up of 4 sub-calculations. Okay, so improving any of these things that I'm going to go through in a second will ultimately also improve your LCP score. So those are optimizing time to first byte, optimizing resource load delay, optimize resource load time, and then reduce the element render delay. So just a couple of thoughts on these. So time to first byte, you type in example.com, you hit enter, the first byte of the HTML arrives, that's time to first byte. So your goal is to try to deliver the initial HTML to the browser as soon as possible, which means, and I just want to point out the losses, you can research guess.js and other things, but ideally you should try to do static site generation as opposed to server-side rendering if you can. Why? Because if you request a page and the server has to generate that, that's going to add potentially milliseconds, but it's still going to add time to the overall time to first byte, right? Whereas if you have pre-built your HTML, there's not even a server involved, it just sends back the response. So try to reduce your time to first byte. Resource load delay. So that's the delta. So the browser received the document, and now it needs to find the LCP. If it's an image, whatever that image is in your HTML structure, it needs to find it. So your goal is to try to reduce the time that it takes for the browser to find and to load the LCP resource. Okay, which means try to use, I think there's a slide on that, try to use fetch priority on the resource, so tell the browser that that is an important resource, so it should start downloading it as soon as possible. Then there's the actual, network transfer time. So, there's an image, if it's 5 megabytes, that's going to take a lot of time to transfer versus an image which is 50 kilobytes, right? So try to create small optimized resources, do image optimization, whether you do it via CDN or whether you do it using one of these tools that I mentioned, it's fine. But just do something so that the size of the image that needs to get transferred over the network is smaller than the original, okay? I always forget to update this slide. It's not side note, it's side note, okay? I'm sorry. Every time I do this, I look at this, I'm like, oh. So, as a side note, in the cases when LCP is not an image, but it's text, it's a paragraph, it's an href, whatever, how fast you load your custom / third-party fonts will also matter. Okay, so I'm just focusing on images, but I wanted to make that side note. So yeah, just try to load those fonts as soon as possible to get a good LCP score. And the reason why I have that asterisk next to the image CDN is because I have an explanation on that. So obviously, having the image, so serving the image from the same origin as opposed to serving it from a third-party CDN or from a third-party site is going to be faster. But on the flip side, usually image CDNs provide you with a lot of additional features that you may not get out of the box if you just serve the image locally. So it's up to you. You have to decide whether you want to use that because you want to use some additional options, maybe changing sizes, whatever, or serve it from the same origin. Okay, and then the last bit is element render delay. So element render delay is the delta between when the LCP resource has arrived and when the browser is actually finished rendering it. Okay, so your goal is to try to render the LCP element as soon as possible, which means don't lazy load it, please. Okay, because these days everyone is like lazy load this, lazy load that. Fine, do that, except for the LCP element. Why? Because the image is there, but you're telling the browser hey, you can wait rendering, just don't do that. So that's going to prolong the LCP, okay? I didn't say that, but LCP is measured in seconds. Okay, so 0 to 2.5 seconds is your target. So you should load the LCP element in less than 2.5 seconds. I was on a site, I think it was an e-commerce site for like swimwear. Every single image, regardless where it was, just had loading lazy. And I was like, okay, whatever, I don't even. But you see the point, right? So loading an LCP via JavaScript, maybe you fetch a JSON file in which you have an image and then you add that to the source. That's going to prolong this LCP. Lazy loading is going to prolong the LCP. So try to avoid all of these. I'm going to show this example to you a little bit later. Okay, so how can you? This is not, but you could call this a checklist. So what can you do to measure the performance? So the one thing that I'm going to just say about performance measurement is, because usually people would go and use DevTools, and they would use Lighthouse, which is built into DevTools. That's great, but once you've done with development, don't run that. And the reason why I say that is because that's not using what is called RUM data, real user metrics. So a much better way to see how your site is performing is to use something like PageSpeed Insights. PageSpeed Insights will return you the very same report, same look and feel, same, what do they call them, same, not tests, or whatever they call them in Lighthouse, except there's going to be an additional section on top, which is going to be real user metric data. And they're going to say, this is data coming from your users, your real users who have visited the site for the past 28 days. That's what you should look at. That's going to tell you how good or bad your LCP is. That's what you need to look at. Because if I run a Lighthouse report on my machine, then on yours, then on yours, then on yours, we're going to get 3 different results. I guarantee that, because different network connections, different CPU, different everything. Okay. But whereas if you look at something like a RUM data, it's going to tell you how the people who visited your site are experiencing your site. Now, the good news is, so this is, on the left you see a couple of screenshots from Lighthouse. So Lighthouse actually does checks for whether you actually serve images in the next-gen format. Those are like AVIF, WebP, etc. They will also tell you whether your LCP was loaded lazily or not, so that's good. But the recent addition to Chrome DevTools is what you see on the right, which is not very visible, but it's fine. It's called the Performance Insights. I think it's still an experimental panel, but you can add it to Chrome. And the good thing about it is, so the screenshot is about the LCP, so you can see it tells you your largest element took 7.51 seconds to load, but what it does, it also analyzes the 4 sort of sub-calculations that I mentioned. So it tells you the time to first byte, the resource load delay, the resource load time, and then the element render delay. Okay, and now you can look into that, and they also give you suggestions as to what you should look into to try to fix your LCP score. Okay, plus in one single view, you can also see which element was taken into consideration. You can actually click that little icon, and that would take you to the Elements panel in Chrome to show you which element was used to calculate the LCP. Okay, so a lot to think about and a lot to do. So can you do all of this in once? Yes, you can. I did say I work for Cloudinary, right? So here comes the Cloudinary pitch. So we do. I'm sorry. It goes hand in hand with the standing ovation. Okay, so with Cloudinary we have a couple of features out of the box, right? So F-Auto, Q-Auto are the most sort of prominent ones. F-Auto being automatic format, Q-Auto being automatic quality. F-Auto, adding F-Auto to the URL, which you see there, is going to serve the most optimal image format to the browser where you make the request from. So if you take F-Auto, you take that URL, you open this from Chrome, you're either going to get a WebP or an AVIF. If you open that link from a browser that does not support either of those, we're going to send probably a JPEG 2000, which is still a better encoding than JPEG itself, and then if we can't, then we send a JPEG. Qauto analyzes the image and is going to apply automatic quality reduction. So for those of you who use things like maybe Photoshop, you save for web or you save a JPEG, there's a quality slider and you can do like 70, 60, etc. Think of this as doing that, but automatically. It looks at the image and it says, okay, this can be a quality 80, the next one, quality 70, quality 85, whatever. So it's going to do that based on the image. What else I want? Okay, the other thing I want to mention is, I think I have a demo on that, but there's a loading mechanism called LQIP, which is low quality image placeholders. I think I have a video on that. So what you see here, not here, but here, is I added a style attribute where I have exactly the same URL. So if you notice, it's cloudy.com image upload, ignore that, and then it's Zurich, right? And then there you have Photo Kyoto, whatever, and then Zurich. In this example, what I'm doing is I create an actual SVG, which is going to have 2 colors and a very low detail. So the reason why I do that is because loading that SVG, which is, I think, if I'm not mistaken, in this case, is about 2 kilobytes, is going to be a lot faster than even loading the 300 kilobyte original image. And so what you can do with that is something like this, right? So you refresh the site and you show something to your users. Okay, I think I do it again. So it shows something like a silhouette of what they are going to see. And then loading, is it double high five? 10 minutes. I thought you wanted. Okay. So 2.8 kilobytes is going to be, you can load that very fast versus the 181. Even though 181 kilobytes is still not that bad. There are a lot of other techniques to load images like that. I can show you some more if you're interested. 2 things I want to point out here. So should you decide for whatever odd and perverse reason to generate all the image formats out there and write all your logic to serve up the right image format for the right browser, then you can use the picture element with the source element to provide a list to the browser. So this is going to try to load the AVIF first. If the browser doesn't support it, then it will try to load the WebP. And if neither of those are supported, your fallback should at all times be a JPEG, because 99.999% of the browsers will understand that. Now, 2 things to note. First one, the order of the source element matters. Okay? If you put, because I've seen that, picture source set equals to whatever the JPEG, and then you put the AVIF next. Okay, the JPEG is going to be loaded, right? So the order of these matter. Okay, so in this case, AVIF WebP JPEG. If you change that to WebP AVIF, it's going to be WebP AVIF JPEG. Okay, so make sure that you take note of that. The other thing is if you have a loading attribute added to the image in a picture element, the value of that is going to be applicable to the source elements as well. So in this case, if I open this HTML page up in a browser that supports AVIF, and I added loading lazy to the image element, then the AVIF will be loaded lazily as well. Okay. Here's a good one. So let me show you this example. So source sets, right? So what I'm trying to do here with source set and sizes is that if the browser window is less than 600 pixels, then load the 400 pixel version of the image. If it's larger than 600 pixels, so the viewport is larger than 600 pixels, then load the with 800 version of the image, right? So you load a larger version of the image. So I wrote this code. This happened a couple of months ago. So I wrote this code. I went to DevTools. And when you have I'm forgetting what that icon is, a little mobile icon in DevTools that allows you to sort of resize your screen. And I had the network panel open, so these 2 things. I was like, okay, so if I'm less than 600, I'm expecting the 400 with image. I spent half a day on this. It always loaded the 800 pixel version of the image. And I went to my colleagues, and I was like, and they didn't know it either. Like, they were like, no, that's, we looked at the code line by line. It's like, it's impossible. Any ideas why that was?
I just
bloody, it's there. Plus, so, where is it? Okay. If you don't have Chrome in full screen, you would never notice that they actually have a drop-down with which you can change the device pixel ratio. And you would never notice, do I have it on the screen? No. You would never notice that 2.0 is the default. So what is that? Device pixel ratio is applicable for Retina screens and modern laptops. They're trying to load twice as many pixels into the same space. So 400 times 2 happens to be 800. So it took me forever to find these 3 dots, realize that there's this option, and then realize that 2.0 is the default. Half a day. Just half a day. Anyway, so FYI, if you have similar issues, check your device pixel ratio. And remember, it defaults to 2. This is the fetch priority. So remember the second optimization for LCP? I mentioned that you can set the fetch priority attribute for your image. So adding this to the head of your HTML is going to load this, whatever image you specify as soon as possible. Okay, so in fact, it's going to be probably the second or the third resource that it starts to download, which means your LCP is going to be much better. I'm going to skip these demo. Okay, so I'll show you a demo in a second. And often when I'm done with the tool, people come to me and say, well, image is fine. No one's loading like a lot of megabytes worth of images. So I think I hid everything. So may I present you anonymous luxury Swiss watch brand, real company, well-known, famous, sell watches that cost like a bazillion pounds. In that carousel, each image is 2 megabytes or above. Okay, they load 1,250 pixel images and shrink it into, or try to contain it in a container which is 190 pixels. So real problem, right? Well-known companies are doing this, and I don't know why. I can tell you which company is this if you're interested. So the demo that I want to show you, if I have, I have time. 3 minutes. Okay. So I created a. How should I? Doesn't matter. So I created a demo which I can share with you. It lives on Netlify. It basically, just by looking at this, you will know that yes, that's the LCP, obviously. In the first scenario, can you see that? Is that large enough? Okay. So in the first scenario, I'm not going to go through this, but basically this is why it's an hour, because I then go through each of the optimization steps. But what you will see, and the way you should check for your LCP as well, is by coming to the performance panel, and there is a section in here called network, and then here, I'm not sure if you can see that, but basically you have a request to the, let me just zoom in, request to the HTML, it requests a JavaScript, which then requests a photos.json file, which then requests the image, and that's the image I'm loading as the LCP. So you see there are lots of steps in between that prolong the LCP score, and then I would go through all these optimization steps, and then if you go to all together and you rerun this performance report, you will see a lot different output, whereby once the HTML is finished loading, you would immediately start loading the image that is considered to be the LCP. And of course, there's lots of other optimizations, right? So instead of the original image, which is a JPEG and it's about 12 megabytes, this is now going to be an AVIF, which is going to be about a fraction of that size. Also notice that you can track the LCP in timings under the performance panel. And just one more thing, which a lot of people just don't know about, which I found, I just find it useful to show, is that if you run, so that's Command-Shift-P, you can run some commands in DevTools, and then there's an overlay for Core Web Vitals. Show Core Web Vitals overlay, and then at all times you would see the 3 Core Web Vitals for any given page, okay, which I found to be just a useful thing to have. Okay. So, I'm sorry if this was all over the place, so I tried to shrink it down to 30 minutes. I'm going to be around and also at the main event tomorrow, so if you want to chat about image formats and stuff, I'm more than happy to talk to you. Otherwise, enjoy the rest of the evening, and thank you.